Most students lose marks on bearing question because they forget one simple rule. Bearing are always measured in a clockwise direction from the north. Essentially, there are two types of bearing. You have the compass bearing that starts either from the north or from the south. And then you have the three-figure bearing that always starts from the north and it is measured in that clockwise direction. So let me show you how to work around this. Take a look at this problem. The bearing of Q from P is 150 degrees and the bearing of P from R is 015 degrees. In this case, we're making use of the three-figure bearing, which means we are starting from the north. If Q and R are 24 kilometers and 32 kilometers respectively from P, what it means is QP is 24 kilometers and RP is 32 kilometers. Calculate the distance between Q and R, correct to two decimal places. So the first thing you would want to do here is to draw the diagram to illustrate this information. So join me as we draw this diagram together. You need to pay attention to this. I will go over the problem again and then we know where to start from. The bearing of Q from P is 150 degrees. That means from P, the word from is very, very important. For you to get the position of Q, you start from P and the bearing is 150. And the bearing of P from R, that means for you to get the position of P, you start from R. You can see how these things are related. To get the bearing of Q, you start from P. To get the bearing of P, you start from R. So the main basis here is R. When we know where R is, we know where P is. When we know where P is, we know where Q is. So, where is R? That's the question. Where is R? We don't have a specific information for where R is, but we know that R is a point, R is a position. So, what we do is to pick a point. Let's pick a point and call it point R. So, I'm going to pick this point. Let me start here because we don't know how this diagram will look like yet. So I'm calling this point R. So this is my R. This is my R. This point is R. This is the north. I'm showing the four cardinals of this now. The north, east, south, and west. This point at the middle here is my R. So let's go back. And the bearing of P from R is 015 degrees. Whenever the angle is less than 100, it usually starts with 0. So that's why you have 015 degrees. So the bearing of P from R is 015 degrees. 015 degrees. Now don't forget we're not doing this by construction. So we're just going to use our discretion to get this done. So let's assume I have 15 degrees here. 15 degrees. I've been told that R to P is 32 kilometers. So let's call this point point R. Let me do this well now. So let's pick this point over here. So we're calling this point point P now. This is 015 degrees. The distance is 32 kilometers. And that's where P is. Again, remember this is not done by construction. So we're just using our discretion here to measure the angles. Alright, get back to the question. The bearing of Q from P is 150 degrees. The bearing of Q from P. So this time around from P, the bearing is 150 degrees. So you start in a clockwise direction, 90. If I get to this point, I would have covered 180 degrees. But it says 150 degrees. So I just need like 60 more after 90 just to get to 150 degrees. And remember, we have been told that the distance QP is 24. So I'm just going to, take this a little bit. That's where your discretion comes in. You ensure that the 24 kilometer is no longer than 32 kilometers. Because if yours is longer, you begin to get wrong values. Alright, so I'm going to pick a point on this line and I'm going to call that Q. This is Q. This is my point Q. All of this is 150 degrees. 150 degrees. Remember that I told you this is 90. Over here is 60 degrees. Alright, so this is point Q. And then what we need to do now is to join this together. Join R to Q. And so you have your triangle formed. Do you understand that? Okay. Please click on the subscribe button if you have not. Follow this page, like, leave your comment below if you enjoyed how we got this diagram. This is the question we are solving. Now the question is, calculate the distance between Q and R correct to two decimal places. Alright. How then do we find the distance between Q and R? So let's call this side small p. That's the distance between Q and R. Let's call this small r, and let's call this side small q. So look at the diagram closely. What are the information we can get in this diagram? As you can see, there are no angles yet. Alright, before I forget, let's call this is 24 kilometers it is giving. PQ is 24 kilometers. There are no angles here. So how do we get the angles here? So pay attention to this. We're just going to make some assumption, very few assumptions. And one of them is, if we assume that this line over here is parallel to this line, then this black line will serve as a transversal. If that is a transversal, then I would say that this angle here, 15 degrees, and this angle here will be alternate to each other. So you would have something that looks like this. These two angles, they are alternate to each other. So I would have that as 15 degrees. So I'm calling this 15 degrees. So this is 15 degrees. And I've told you my reason, alternate angles. Alright, now look at all of this angle you have here. All of this is angles on a straight line. And the sum of angles on a straight line is 180, right? Okay. So remember you got this from here to this point as 150. So the remaining portion here will be 180 minus 150. Or you look at it as if this is 90 and this portion here is 60, then the remaining one here will be 90 minus 60, which is 30. So whichever way you're looking at this is going to be 30 degrees. And everything you have here will be 15 plus 13, which is 45 degrees. I hope you got that. Alright, so now let's find side RQ. I've called that Q, I mean P. In this question now, I'm going to teach you how to use the cosine rule. Because the best way to solve this is to use the cosine rule here. Is that clear? Alright, so look at the cosine rule now. The cosine rule states that the square of a side, P square, is equal to the sum of the squares of the other two sides, Q square plus R square, minus the product of 2 and the other two sides, cos P. That's angle P. So here P square equals to my Q is 32 square plus R 24 square minus 2 times 32 times 24 cos 45 degrees. Alright, so P square is equals to, what's the value of 32 square? 32 square is 1000, 24, 24 square is 576 minus 2 times 32 times 24. I have 1536, then times cos 45. Cos 45 is root 2 over 2. In decimal, that will be 0.7071. So here I have P square equals to, be careful here, 1024 plus 576 is 1600. You can't add up this and this. Please be careful there, because this represents product, so you need to get a product. Minus 1536 times 0.7071. That gives us 1086.11. So here we're subtracting 16,000 or 1600 minus 1086.11. This is 513.89, and you have P to be equals to the square root of this 513.89, and the square root of 513.89 is 22.669 kilometers. Remember, you've been told that correct your answer to 2 decimal places. So to 2 decimal places, you start counting after the decimal point 1, 2. The next number here is more than 5, so you round it up 22.67 to 2 decimal places. And that's the distance between R and Q. I hope you understand that. The next question is, find the bearing of R from Q. Find the bearing of R from Q. So how do you do that? So let's go back. The bearing of R from Q. That means we're starting from Q. The bearing of R, this is where R is, from Q. So you start from Q and you go in a clockwise direction up to the line that join R and Q together. So all of these represents the bearing. And from what I have, from this point to this point is 180 degrees angles on the straight line. If we can find this angle, we'll say that the bearing of R from Q is 180 degrees plus this angle here. But we don't know this angle. How do we find that angle? Now, this angle here is alternate to this angle over here. Everything you have here. In that case, I am assuming that this line and this line over here, they are parallel to each other. And so this will serve as a transversal. So if I extract that out, I'll have something like this. And then I have this line. So I have all of this to be equal to this. That is alternate angle. That's one way we can look at this. That's one way. Another way we can look at this is to consider this angle here. This angle here is 30 degrees because it is alternate to this 30 degrees. We can find this angle here. When we find this angle here, we would say that everything you have here back to this point is angles at a point. And the sum of angles at a point is 360 degrees. So we'll be able to find that bearing. So I just want to go with the first method. Yeah. Okay. So if I call this, what should I call this now? Okay, let me call this A degrees. Remember I said all of this angle here is A degrees. I already have this as 15. I just need to find this angle inside. Once I find this angle inside, I add it with 15, and that's A degrees. Again, I just need to find this angle here. I've told you that all this angle from here to here is alternate to this A. They are alternate angles. You can see that they are alternate angles. So I need to find this angle inside at point R. How am I going to find that? So let me write first of all that the bearing of R from Q would be, I've told you that this is angles on a straight line. This is angles on a straight line. Look at the black angle here. This is angles on a straight line, and that is 180 degrees. So the bearing of R from Q will be 180 plus A. So let's write that here. The bearing of R from Q is 180 degrees plus 8 degrees. So now how do we find A? Remember I said we need to find this angle here. Alright, let's get back. We have already found the value of P as 22.67 kilometers. In this case, I'm going to teach you how to use the sine rule. We can also use the cosine rule to find this angle, but the sine rule seems a bit faster here now, since we have the value of P. Now, the sine rule states that the ratio of the sine of an angle to the opposite sides are equal. That is, the ratio fraction sine r to the opposite side small r will be equals to sine p over small p. So I have sine r over small r, that should be 24 kilometers. So this is 24 equals to sine p, that's 45 over 22.67. So cross multiply this, you have 22.67 sine r equals to 24 times sine 45. So my sine r will be 24 sine 45 all over 22.67. So sine r is equals to 24 times 0.7071 divided by 22.67. And we're almost done with this. R is equals to 24 times 0.7071 divided by 22.67. And so this is 0.7486. 0.7486. So the value of R, let's find the sine inverse of this. 0.7486, and that is 48.47 degrees. So R is 48.47 degrees. Let's get back to the diagram. So this is 48 points. What did I have there again? 48.47 degrees. So the entire angle of A is 15 plus, so my entire A is 15 plus 48.47 degrees. So if we add this together, 48.47 plus 15 will give you 63.47. So therefore, the bearing of R from Q is 63.47 plus 180. When you add this together, you have 243.47 degrees. And that's the bearing. Please click on the subscribe button I want to believe you've learned something from this problem. I'm going to see you in the next class.